Hey everyone, we're doing worksheet on linear inequalities. So let's start right away. Question number 1, part A. We have 3n minus 11 greater than 5n minus 18. Let's take 3n to the other side. So it becomes 5n minus 3n. And then let's take 18 to the other side, which makes this 7 greater than 2n. And then to find n, take 2 to the other side, it gets divided and we get n, this symbol, and 3.5. You may write it like this or you may write it like this. They both mean the same. Less than less than 3.5. Now, in case you don't know, keep this in mind that the side that has a single corner is always less than. So both of them read as n is less than 3.5 or 3.5 or n is less than 3.5. Both of them mean the same thing. Okay, this was part A. Part B. Which is 3n minus 5 greater than 17 plus 8n. Again, I'm going to move this 3n to the other side so that we avoid getting negative power of n. That requires some other additional working that we're trying to avoid for now. So 8n minus 3n and minus 5 minus 17. Always try to rearrange an inequality in such a way that your variable's coefficient is positive, not negative. Okay, so this becomes 5, 6, 7, 8, yes, 5 and greater than minus 23 and then minus 23 over 5 greater than n. This gives us minus 23 over 5 gives us minus 4.6. Oh, that was 22, not minus 23. So let's make this correction quickly. This is minus 22. I hope nobody heard that. Alright, so this is minus 22 and then minus 22 over 5 would give us minus 4.4. So please make this correction. Part C. 7 minus 8x is greater than equal to 19 plus 2x. So taking 8x to the other side to make it positive, so this becomes 2x plus 8x. Again, I'm repeating that in inequalities, it's better to rearrange the values in such a way such that the coefficient of x becomes positive. Alright, and then we have 7 minus 19. This will become minus 12 greater than equal to 10x, and then x is this symbol minus 1.2. Again, this can be written like this or like this. Both mean that x is smaller than minus 1.2. Alright, why do I keep telling you to ensure that the coefficient of x square is positive? So that we don't have to take care of a step that the students usually forget if they make the coefficient of x negative. Let's say I keep 8x here, minus 8x here, and bring minus 2x here as well, and here I get 19 minus 7, which gives me 12, and here I get minus 10x. Now the second last step would be to take minus 10 to the other side and divide it to the other side. x is uh, we'll have to put a sign over here, divided by minus 10. Now you need to keep this in mind that whenever you multiply or divide with a negative number, you are supposed to flip the inequality, and then you will get the right answer. Here we get the same answer as before, but keep this in mind that if in the second last expression your coefficient of x is negative and you have to multiply a negative number on to the other side or divide a negative number to the other side, you have to flip the sign of the inequality. So in order to avoid this, it's better to rearrange in such a way that the coefficient of x is positive. Okay. Next part D. 6n plus 3 greater than 8n. I'll keep 3 here, take 6n to the other side, it will become 2, and then n is the symbol 1.2. Write it like this or write it like this. Both mean n is smaller than 1.5. Part E. N plus 7 less than 5n minus 8. Taking n to this side, it becomes 4. Bringing 8 to this side, this becomes 7 plus 8 is 15, and then n is greater than 15 over 4, which gives us n is greater than 15 divided by 4 is 3.75. So either write it like this or n is greater than 3.75. Since n has the two ends of the inequality, that means n is bigger, and 3.75 has one end of the inequality, so it is smaller. That's how I tell my students to remember how to read this. This is n is greater than 3.5, and this is also n is greater than 3.5. Next part F, which is 5t plus 23 less than 17 minus 2t, which gives us 5, 6, 7t less than 17 minus 23, which gives us minus 6, and then t is less than minus 6 over 7. Next part G, which is 3x minus 1 less than equal to 11x plus 2. Bringing 2 to the left hand side, we get minus 3. Taking 3 to the right hand side, and we get 8x, and then to find x, we'll divide this with 3. So either write it like this or x is greater than equal to minus 3 over 8. Next up is part H. So 7x minus 5 greater than 3, 2 minus bracket 2 minus 5x. So this becomes 7x minus 5 greater than 6 minus 15x, which becomes 7 plus 15 is 22, and 6 plus 5 is 11. This was 22x, so x will be greater than 11 over 22, which means 1 by 2. So n is greater than 1 by 2, or n is greater than half, like written over here. Okay. Next up is part I. Okay. 5x minus 4 less than 3, 12 minus x. So open the brackets, 5x minus 20 less than 3 times 12s are 36 minus 3x. Take 3x to the other side, it will get added to 5. 8x less than 36 plus 20 is 56, and x is less than 7. Next is part J. X over 2 minus 13 greater than 12 plus 3x. So I'll take 13 to the other side. In fact, I'll take half x to the other side so that I get a positive coefficient of x, and bring 12 to this side. So minus 13 minus 12 greater than 3x minus x by 2, which is half x. So this becomes 5 minus 25 greater than, let's take LCM, 6x minus x, which gives us minus 25 greater than 5x over 2, which gives us minus 50 greater than 5x. So x is less than minus 10, or write it like this: x is less than minus 10. Control, sorry, I was teaching you how to delete the board on this software. Okay, 2x minus 3 over 5 minus x over 3 less than equal to 2. So take LCM first. So the LCM is 15. 3 times 2x minus 3 minus 5x less than equal to 2. So this becomes 6x minus 9 minus 5x less than equal to 30. So this becomes x less than equal to, take 9 to the other side, add it to 30, and we get x is less than equal to 39. Part L, which is 6 times 2 minus 3x minus 4, 1 minus 2x less than equal to 0. Opening up the brackets, we get 12 minus 18x minus 4 plus 8x less than equal to 0. So we get 8, and here, and let's take 18x minus 8x to the other side, which gives us 10x. So x is greater than equal to 0.8, or write it like this: x is greater than 0.8. Both mean the same thing. Part M, two x plus 1 over 3 less than equal to 5x minus 8 over 4. 8x plus 4 less than equal to 15x minus 24. So 15 minus 8 is 7x, and this becomes 28. So x is greater than equal to 4, or write it as x is greater than equal to 4. Part N, part N is 2x plus 5 less than x minus 1 over 4. We can cross multiply, and let's take 4 to the other side. 4 times 2x plus 5 will become 8x plus 20 less than x minus 1. So 7x less than minus 21, x is less than minus 3. Part O, x over 3 plus 5 greater than 2. This becomes x plus 15 over 3 greater than 2, or we could have done something easier. Let's take 5 to the other side, which will make this minus 3, and then this becomes x is greater than minus 9. Part P, which is x over 2 plus x minus 2 over 3 less than 5. Take LCM first. 6, 3x plus 2 times x minus 2, so 2x minus 4 less than 5. Take 6 to the other side, multiply it with 5. Before that we get 5x minus 4 less than 30. 5x less than 34, and x is less than 34 over 5. 6.8. Question number 2, part A. List the positive integers that satisfy the inequality. Part A. X plus 13 greater than equal to 3x plus 7. So this becomes taking 7 to left hand side and x to the right hand side. We get 2x here and we get 6 here, and then we get x is less than equal to 6. So on a number line, this would mean that if we have 6 here and 7 here and 5 here and so on, x is less than equal to 6. Why are we saying x because is less than and equal to 6? Because remember, if the inequality has one end towards x and two ends towards 6, that means x is smaller than 6. So we put a circle on 6, fill it up because we have to include 6 as well, and then we go towards the left because x is less than equal, sorry, this should give 3, so this number line will be 3, 4 and 2. So x is less than equal to 3, that means we'll include 3, then we'll include 2, then we'll include 1, and the question says list the positive integers only. So positive integers will end at 1 and we won't go beyond 1, we won't include 0, minus 1, etc. So this is the answer for part A. Part okay. Part B. Find the positive integers that satisfy the inequality t plus 2 greater than 3t minus 6. So take t to the other side, it will get subtracted with 3t and we'll get 2t. Take 6 to the other side, it will get added to 2 and we'll get 8. So then we get t is smaller than 4. So on a number line again, in case you want to draw a number line, although it can be done without that, 4 and then smaller numbers would be 3, 2, 1. So we're not including 4 this time because it does not have equals to sign with it. So the answers are simply 3, 2, 1, and we won't include 0 and the negative numbers, etc., because the question says find positive integers. So the positive integers are only 3, 2, 1 in this case. Part C. Part C is solve the inequality for the positive integer values of x when 21 plus x over 5 is greater than x plus 1. So first we have single fractions on both sides, so we can cross multiply 21 plus x greater than 5x plus 5. Next I'll be moving this x to the other side and 5 to this side, so 21 minus 5 becomes 16 greater than 5x minus x becomes 4x. So in the end I get x is greater than 4. 16 divided by 4 is 4. Now the question again says positive integer values of x. So we are looking for values smaller than 4, not including 4. So that would be 3, 2, 1. So the answer should be 3 to 1. It's the answer is just like the last part, but in this question where in the answer, in the marking scheme, you're also given this 0 in brackets. This means that even if students include 0 or doesn't include 0, do not deduct marks. Alright, because 0 is neither considered as a positive integer or a negative integer. So even if you include it, it doesn't matter. If you don't include it, doesn't matter. Okay. Part D. Find the integer values of n that satisfy the inequality 15 less than equal to 4n less than 28. Now this has to be split in two parts. First we'll use this region and we'll write 15 less than equal to 4n. Next we'll be using this portion and we'll write 4n is less than 28, and then simplified we get 15 over 4 less than equal to n, and as a mixed fraction I'll write 3 whole 3 by 4. Alright, and the other inequality would be written as n is less than 7. So now I'll have to write these two by combining the inequalities, the given two inequalities. So I'll write n, and I'll always write these symbols around n. So n is bigger than what? N is bigger than 3 whole 3 by 4. So n is bigger than 3 whole 3 by 4, and there's also an equals to sign with it. And n is less than 7. Now the question says find the integer values of n. So we can't be using decimal values or fractions. We'll be using integer values that are whole complete numbers. So we have 3 whole 3 by 4. After that this is 3 point something, and then we'll have a whole number 4, then 5, then 6, then 7. We have to take integer values in this range. 3 whole 3 by 4 is included, but 7 is not included. So the three integer values in this range are simply 4 and 5 and 6. So these values are your answer. Not 7, because the inequality does not have an equal to sign with 7, and not 3 whole 3 by 4, because the question clearly states that we need integer values. Part E. Find the integers that satisfy the inequality minus 5 less than equal to 2 and minus 1 less than equal to 5. Again we'll split it in two parts. This would be the first part. So I'll write minus 5 less than 2n minus 1, and this would be the other part. So I'll write 2n minus 1 less than equal to 5. Simplified, this becomes a minus 1 plus 1 is minus 4 less than 2n, and minus 2 less than n. And here we get 2n less than equal to 6, and n is less than equal to 3. And like we just discussed, first we have to write down n in between and then these two signs in between. This is showing n is bigger than. So n is bigger than what? N is bigger than minus 2, and n is smaller than sorry, this does not have an equal to sign. N is bigger than minus 2 and n is smaller than equal to 3. So on a number line we'll write minus 2, minus 1, 0, 1, 2, 3. 3 is included, but minus 2 is not included. So the integer values in this range are minus 1, 0, 1, 2, and 3 as well. Okay. Part F. Find the integer values of n that satisfy this inequality. Split it into two, first this part and then this part. So we get minus 7 less than 4n and 4n less than equal to 8. this becomes n is greater than minus 7 over 4, and as a mixed number this becomes 4 whole minus 1 whole 3 by 4, yes, less than n. And then we get n is less than equal to half. So combined this can be written like this, and n is greater than minus 1 whole 3 by 4, and n is less than equal to half. So we need integer values in this range, so we have minus 1 whole 3 by 4 here, and we have half here. So in this range we'll get, oh, in fact that was not half, that was 2. So let's quickly correct this. This is 2. So we have 2 here. Why won't it write? Okay, here we go. Less than equal to 2. So less than equal to 2, and we'll have 2 here. So we're looking for values bigger than minus 1 whole 1 by 2 and greater than equal to 2. 2 is included. So what would be those values? Values smaller than 2 would be 1, and then 0, and then minus 1, and then not minus 2, because minus 2 would be even smaller than minus 1 whole 1 over 3. So the integer values in this range would be minus 1, 0, 1 and 2. This is the answer for this part. Part G. Find integer values of n that satisfy the inequality 18 minus 2n less than 6n less than equal to 30 plus n. Okay, so rearrange, first we'll use this side. So we'll write 18 minus 2n less than 6n, and then we'll use the right hand side. 6n is less than equal to 30 plus n. This gives us 18 is less than 8n, which gives us n is greater than 18 over 8. Simplified, this becomes 9, this becomes 4, and in mixed form this becomes 2 whole 1 by 4. Now let's solve this side. So take n to the other side, it will get subtracted with 6n. We get 5n less than equal to 30, which gives s n is less than equal to 6. So combined we'll write it as n is greater than equal to 2 whole 1 by 4 less than equal to 6. So on a number line we have 6, which is included, then we have 5, then we have 4, then we have 3, then we'll have 2 whole 1 by 4, and then we'll have 2. So in between these two the integer values are 3, 4, 5 and 6 only.